Have you ever imagined a place where the night sky is illuminated by two moons, the air is pure, and water is never scarce? It sounds like something out of a dream, but believe it, scientists are getting closer to discovering planets that surpass Earth in terms of habitability. NASA has unveiled findings that could change everything we know about our place in the universe. Here's the question to provoke your thoughts. What if Earth isn't the best place to live? Perhaps we are only beginning to uncover cosmic paradises ready to host humanity. But hold on, it's not as simple as it sounds. While exploring these possibilities, we also face significant challenges. Do we have the technology to reach these planets? Or even to confirm that they can sustain life? In today's video, you'll discover which extraordinary worlds could become our Plan B, or even Plan 8. Get ready to dive into a universe of science, curiosity, and technology, where the search for new cosmic homes reveals more about ourselves than we could ever imagine. Why won't Earth be habitable forever? The future of Earth is something that seems so far away that we rarely think about it. But understanding how the sun works reveals that our planet won't last forever. Our sun, a seemingly calm star, is constantly undergoing transformation. It shines because it converts hydrogen into helium, releasing colossal amounts of energy. However, in billions of years, that fuel will run out, and the sun will expand into a red giant. Imagine this: our planet, teeming with life today, could become a scorching ball of fire, much like Venus, baking under an unbearable heat. And long before that happens, climate changes will make life here impossible. So, what can we do in the face of this inevitable reality? This is where the incredible power of human curiosity comes into play. Since we've understood how the sun ages, scientists and researchers have tirelessly worked to explore solutions. One such solution is finding a new home for humanity. This idea isn't science fiction, it's technology in progress. The search for habitable planets begins with powerful telescopes like the James Webb, which allow us to observe worlds millions of light years away. But what makes a planet habitable? Are we ready to understand these criteria and use our science to secure the survival of our species? What are exoplanets and how are they discovered? Exoplanets, as their name suggests, are planets orbiting stars outside our solar system. The idea of their existence seemed remote just a few decades ago, but technology has completely changed that scenario. Today, thanks to telescopes like Kepler and James Webb, thousands of them have been identified. One of the most common methods for discovering them is transit, which measures the dimming of a star's light when a planet passes in front of it. It sounds simple, but imagine the precision needed to detect such a small variation from light years away. In addition, science has advanced with methods like spectroscopy, analyzing starlight to reveal information about these worlds' atmospheres. Human curiosity has led us to discover worlds we never imagined possible. Some of these planets have extreme conditions, while others, surprisingly, may have characteristics similar to Earth. But how do we know if they are habitable? To answer that, scientists combine data on temperature, atmospheric composition, and even gravity to determine whether they could support life. It's like piecing together a cosmic puzzle where every piece represents a technological breakthrough. And as we learn more about these planets, the question becomes irresistible. Are their worlds better than Earth? That's where the real fascination begins. Planets better than Earth? The idea that planets better than Earth might exist feels straight out of a science fiction movie, but it's a possibility science takes seriously. Imagine living in a place where natural resources are abundant, the climate is stable, and the atmosphere is as good, or even better, than ours. Exoplanets known as super-Earths are fascinating examples of this. These planets are larger than Earth but may have more moderate climates and stars that last billions of years longer than our Sun. It's a perfect combination to ensure the survival of a civilization for an extended period. But what makes these worlds better? It starts with the star they orbit. Some stars, like orange dwarfs, are more stable than the Sun and emit less harmful radiation. Additionally, Many of these planets are located in habitable zones where liquid water can exist, a crucial condition for life. While curiosity drives us to explore these possibilities, one pressing question remains: what would it be like to live in such a place? And more importantly, how do we evaluate these planets to determine if they are indeed better than our Earth? To answer this, let's take a closer look at a special candidate, Kepler 452b. Kepler 452b, Earth 2.0? Kepler 452b is the exoplanet most similar to Earth among those we know, and it's no wonder it's called Earth 2.0. This distant world orbits a star very much like our Sun, located in the Cygnus constellation about 1,800 light-years away. The most intriguing aspect is that it lies in its star's habitable zone, a region where temperatures allow liquid water to exist. Furthermore, Kepler 452b is approximately 60% larger than Earth, placing it in the super-Earth category. This means it has stronger gravity, which might pose a challenge for human adaptation, yet its similarities remain captivating. On the flip side, exploring Kepler 452b is far from straightforward. Its colossal distance makes any journey impossible with current technology, and we still know little about its atmosphere. Is it dense enough to shield its surface? What if the planet experiences extreme weather conditions, such as perpetual storms? These questions intrigue scientists who rely on advanced instruments to uncover the secrets of this potential new home. Despite the challenges, Kepler 452b remains a gem among discoveries. But what about closer planets? Proxima Centauri b seems like a good starting point for dreaming of a second home. Proxima Centauri b, the closest plan B? Proxima Centauri b is the closest exoplanet to Earth, orbiting the star Proxima Centauri, just 4.2 light-years away. This small world is located in the habitable zone of its star, meaning it has the potential to support liquid water, an essential condition for life as we know it. Scientists were immediately intrigued upon its discovery, as its proximity makes it a more realistic target for exploration in the future. Unlike Kepler 452b, a mission to Proxima Centauri b could become feasible within a few decades with the right technological advancements. However, not everything about this potential refuge is perfect. The star it orbits, a red dwarf, is known for violent solar flares that could render the planet uninhabitable. Moreover, Proxima Centauri b may be tidally locked, with one side always facing the star while the other remains in perpetual darkness. This creates extreme climate conditions that are difficult to endure. Despite these challenges, Proxima Centauri b remains one of our best bets, both for its proximity and potential. And if you think this is intriguing, wait until you learn about the fascinating TRAPPIST-1 system, which takes the concept of habitability to another level. TRAPPIST-1e and the 7 habitable planet system. TRAPPIST-1e is one of the most promising planets in the TRAPPIST-1 system, a fascinating collection of 7 exoplanets located about 39 light-years away. What makes this system unique is that all its planets are incredibly close to their star, an ultra-cool dwarf. TRAPPIST-1e in particular lies in the habitable zone, where temperatures might allow for liquid water. The planet has a size and density very similar to Earth's, and scientists believe it could have an atmosphere capable of sustaining life. It's no exaggeration to say that the TRAPPIST-1 system is like a playground for science. But it's not just the climatic conditions that draw attention. The proximity of the planets in the TRAPPIST-1 system allows you to see the other worlds with the naked eye, like moons in the sky. This opens up incredible possibilities for studies and, who knows, future interplanetary colonization. However, the close orbits also create gravitational instabilities, and the tidal locking of the planets results in one side always illuminated while the other remains dark, challenging habitability. Still, the potential of TRAPPIST-1e is inspiring. But is humanity ready to face the challenges of living on exoplanets? That's what we'll explore next. The challenges of living on exoplanets. The idea of living on an exoplanet is fascinating, but it's far from simple. Each world outside the solar system presents unique challenges, such as toxic atmospheres, extreme gravity, or temperatures unsuitable for human life. For instance, many exoplanets experience tidal locking, where one side is always facing the star while the other remains in eternal darkness. This creates extreme climates, one side scorching hot, the other frozen solid. Additionally, the radiation emitted by stars, such as red dwarfs, can be devastating for any unprotected form of life. These problems aren't just theoretical, they demand rapid scientific and technological advancements to create viable solutions. Imagine needing to build artificial atmospheres or radiation shields to survive on a new planet. And that's not even considering the transportation and adaptation challenges posed by different gravitational conditions, which could affect human physiology. Despite these obstacles, curiosity drives us forward, and scientists continue to explore ways to overcome them. But before colonizing any world, we must understand what truly makes a planet habitable. And that's the question we'll address next. How does science define a habitable planet? A habitable planet must meet strict criteria, starting with its location in the habitable zone. This is the region around a star where temperatures allow liquid water to exist, a fundamental ingredient for life. But this is just the beginning. The type of star the planet orbits is also crucial. Highly unstable stars, like red dwarfs, can emit intense radiation that makes life difficult. On the other hand, stable stars, like orange dwarfs, provide a more conducive environment for the development of complex organisms. Another essential factor is the planet's composition. It must be rocky, like Earth, and possess an atmosphere that protects against radiation and maintains ideal temperature conditions. Moderate gravity is another key element, as it influences the retention of the atmosphere. Additionally, the presence of carbon, nitrogen, and oxygen in the atmosphere increases the chances of habitability. However, each of these elements is a piece of a larger puzzle, and scientists use technology to connect the dots. Speaking of technology, have you ever wondered how we might reach these worlds? The answer lies in the next topic: the technology needed to reach exoplanets. Reaching an exoplanet is one of humanity's greatest challenges, and current technology is far from capable of getting us there. To illustrate, Proxima Centauri b, the closest exoplanet, is 4.2 light-years away. With today's fastest spacecraft, it would take tens of thousands of years to reach it. Solutions like nuclear-powered ships or solar sails are being explored, but they remain theoretical. Meanwhile, science progresses with increasingly powerful telescopes to study these distant worlds remotely. Ambitious projects like Breakthrough Starshot aim to revolutionize interstellar exploration. This initiative proposes using small devices propelled by laser beams to achieve incredible speeds, making interstellar travel possible within decades. However, the cost and technological complexity are enormous, requiring global cooperation and decades of development. Even with these advances, a significant challenge remains: how to create a system capable of sustaining life during such a long journey. We are just at the beginning of this journey, but human curiosity knows no bounds. And of course, this leads us to a bigger question: are we alone in the universe? Are we alone? The search for life on other planets. The search for life on other planets is undoubtedly one of humanity's greatest questions. With billions of stars in our galaxy and trillions of galaxies in the universe, the idea that we're alone seems improbable at best. Scientists have used science and technology to look for signs of life, from microorganisms to advanced civilizations. Modern telescopes like the James Webb analyze exoplanet atmospheres for gases such as oxygen and methane, which could indicate biological processes. Every discovery, no matter how small, fuels our curiosity about who or what might be out there. But it's not just about finding life, it's about understanding our place in the cosmos. The possibility of another civilization existing completely changes our perspective on existence. What if there's already life on planets like TRAPPIST, 1e, or Proxima Centauri b? How would our first contact look? Although we don't yet have concrete evidence, the progress in searching for habitable exoplanets is a significant step forward. With each new planet discovered, it feels like we're getting closer to answering this ancient question. Now that we know so much, the real question is, are we ready to apply this knowledge and explore new frontiers? Now that you know planets better than Earth might exist, the question remains, are we ready to explore these new frontiers? Science has shown us the vast possibilities, but are we bold enough to take the next step? Perhaps the biggest challenge isn't just exploring the cosmos, but rethinking how we care for our own planet. After all, if we can't preserve Earth, what guarantees we'll do better in a new world? So, what would you do if you could live on one of these planets? Share your thoughts in the comments. Don't forget to subscribe to the channel and activate notifications to keep learning about science, technology, and the incredible curiosities of the universe. Your support is the fuel for our explorations. See you in the next video. Until then, keep dreaming big and gazing at the stars.